I have my setup ready to go here. And as we begin our study of calculus this year, we start with a review of what we know about functions. We use calculus to analyze functions. We look at how functions are changing, how they change by taking derivatives, and we add up changes in the function. So we add up the functions by integrating them. But every problem starts with a function, and a lot of problems that students have, a lot of their difficulties stems from the fact they don't really understand how to draw a function, what it looks like, or what its properties are. So we'll start calculus again in this chapter where we're going to review functions. So you see as the basic, let me get my pen going here. A basic picture of a function I have here is something they call the machine model. And what a function does is it takes an input, takes one input, and the function operates on that input and produces an output. Okay? Every function has its has some properties to it. We have something we call a domain, which I'd call just valid inputs. What are the valid inputs for those functions? Not every function can handle all different kinds of inputs. There's a valid input, and it's called the domain. And when we talk about the output of the function, we might describe that by the range of a function. And a range is defined as valid outputs. And a lot of times it's defined as f of x being greater than some min. You'll give it some min value, might be equal to also, and then less than or equal to some max. So what is the range? What's the min to the maximum values afforded there? Notice also up here at the title I have functions and models. You remember we'll change pen color here just for green. We got models too. So what are functions? Functions are, again, we're going to try to put a mathematical representation on real life, and we might call that a model of real life. Our models might be good. They might be very accurate in representing the physics of the problem, or they might be very bad. So we might call them, and might be some research done to try to improve these models. So you'll see in a function, again, once again, there's an input into the function and you get an output. Another way of representing things, and again, a lot of times in math, the difficulty stems from notation. And we might call this function a set of ordered pairs. And a set of ordered pairs x, you give me x, and I'll give you back an f of x. Okay? So a set of ordered pairs x and f of x such that, oops, get back my pen here, such that x, again, is an element. That's what that E means, in the domain. In the domain, what is the domain? It is the legal set of values, valid inputs for the function. And what we're going to do in this chapter is review some of the properties of functions and then give you some functions you should be familiar with before we go into our study of calculus. A calculus problem can present a function to you in a variety of different ways. One of the most common ways to give you a function is to do it algebraically. I keep losing this pen. Okay, and that's what your algebra. And And what would be an example of that? I might say a function g of x is equal to the square root of 4 minus x. Okay? And when we looked at such a function here, since we're talking about range and domain, what is a legal input for this function? Well, we know the square root, which is a square root function, has to operate on positive inputs, right? So 4 minus x has to be greater than or equal to 0, or you'll see that would mean x has to be greater than, or x has to be less than or equal to 4. Okay, so this is what I would say would be my domain. That would be the domain for this function. Maybe more properly, I might say x is less than 4, greater than infinity, negative infinity. Okay, there is my domain. So anyway, here's a algebraic representation of a function. Also might get a graphical representation. A graphical representation. And in that case, in the case of a graph, then, we might give you set up ahead of time here, but we'll give you a graph. In this particular function here, we know x is less than 4. So we're going to go 4 here. And as x, I could plot another little point here. This is what? 4, 0. If I put in x equal to 0, I'm going to get 2. In this case, let's see. Okay, so this is a graphical representation of a function. Again, we could give you the function. We could ask you, well, what is its range? What is its range, maybe? That would be, you could have asked you the same question here. But for range, we'll do it. The range, what are the valid outputs? Well, the outputs could go from, that's the y, that would be the y-axis here, would be the outputs, y equal to g of x. Again, the notation being, well, I could reference this axis as being y, or g of x. And then this axis here, I guess let's change back to red, this value x, and this could be y. So again, range, I might say something like, well, g of x is what? Well, it's greater than or it's equal to 0. And then is there any maximum? Does it hit a max as it goes up here? Well, no. As this gets more negative and more negative, this keeps growing. So this is, for range, I might say something like that. Or I might even put y in here. Also, I could reference, I might give you this function not with an algebraic, not with, not with a graphical representation, but we'll go green here. I might go with a numeric. A numeric representation. And what would that be? That might be I give you points on this curve. So I might give you that point here. I might give you, let's see, that point here. Oops. This point here. So I might just give you points on the curve and say this is, it's 4. I guess that's going to go -2. I guess that's going to go -4 for symmetry, 0. Make that 2, make that 4. So my table might look like something like this. X, g of x, when x is -4. Well, if I put in -4 in here, I get 8. So I won't simplify this. I'll just put it in square root of 8. When I put in a minus 2, put in a minus 2 here, I get the square root of 6. When I put in 0, I get the square root of 4, which then I put as 2. When I put in 2 up here, I get the square root of 2. And last here, if I can get this on here, when I put in 4, I get the square root of 0 equal to 0. Okay, so you see I've given you 3 different ways to represent that function. And in our next video, we'll give you another way. We're going to talk about just with a verbal description. Then we'll talk about some properties of these functions and give you kind of a library of functions you really should be familiar with before we start into calculus. See you soon.